My name is Jim Al-Khalili, and I'm a professor of physics at the University of Surrey. Studying the innermost secrets of atoms and their nuclei has been at the heart of my working life. But there's another side to me. I was born and grew up in Baghdad to an English mother and Iraqi father, but left Iraq with my family in the late 70s when Saddam Hussein came to power. By then, science was already my great passion in life, and as I studied it further, I saw myself fully part of the Western tradition, inspired by names like Newton and Einstein. But buried away was this nagging feeling that I was ignoring part of my own scientific heritage. I still remembered my school days in Iraq and being taught of a golden age of Islamic scholarship, that between the 9th and 12th centuries, a great leap in scientific knowledge took place in Baghdad, Damascus, Cairo and Cordoba. So I want to unearth this buried history, to discover its great figures and to assess exactly what their contribution to science really was. Are there medieval Muslim scientists who should be spoken of in the same breath as Galileo or Newton or Einstein? And crucially, what is the relationship between science and Islam? My journey into the science of the medieval Islamic world will take me through Syria, Iran and North Africa. I started in the back streets of the Egyptian capital, Cairo, with the realization that the language of modern science still has many references to its Arabic roots. Take scientific terms like algebra, algorithm, alkali. I instantly recognize these words as Arabic. And these are at the very heart of what science does. There will be no modern mathematics or physics without algebra, no computers without algorithms, and no chemistry without alkalis. Surprisingly few people in the West today, even scientists, are aware of this medieval Islamic legacy. But it wasn't always so. From the 12th to the 17th century, European scholars regularly refer to earlier Islamic texts. I have here copies of some pages of the book Liber Abaci by the great Italian mathematician Leonardo Pisano, otherwise known as Fibonacci. What's fascinating is that on page 406 is a reference to an older text called Modum Algebra et al-Muqabala, and in the margin is the name Mahomet, which is the Latinized version of the Arabic name Muhammad. The person he's referring to is Muhammad ibn Musa al-Khwarizmi. In fact, Arabic names crop up in many medieval European texts on subjects as varied as map-making, optics and medicine. But I want to start with al-Khwarizmi because his work touches on a crucial aspect of all our lives today. It's thanks to al-Khwarizmi that the European world realized that their way of doing arithmetic, which was still essentially based on Roman numerals, was hopelessly inefficient and downright clunky. If I ask you to multiply 123 by 11, you may even be able to do it in your head. The answer is 1,353. but try doing it with Roman numerals. You'd have to multiply CXXIII by XI. It can be done, but trust me, it's not fun. Al-Khwarizmi showed Europeans that there's a better way of doing arithmetic. In his book entitled The Hindu Art of Reckoning, he describes a revolutionary idea. You can represent any number you like with just 10 simple symbols. The idea of using just 10 symbols, the digits from 1 to 9 plus a symbol for 0, to represent all numbers from 1 to infinity, was first developed by Indian mathematicians around the 6th century AD, and I can't overstate its importance. Let me show you. Here are the numbers in Indian Arabic numerals. 1, 2, 3, 4, 5, 6, 7, 8, 9. And here are the numbers we're more familiar with in the West. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can see the similarity between these numbers, in particular, for instance, the digits 2 and 3. If I tip this sideways, you can see now how they look like numbers 2 and 3. And what's powerful about these digits, this numerical system, is how it's simplified arithmetic calculations. But Al-Khwarizmi and his colleagues went further than just translating the Indian system into Arabic. They created the decimal point. This text, written a century after Khwarizmi, is by a man we know only as Al-Uqlidasi. Here he shows that this same decimal system can be extended to describe not just whole numbers, but fractions as well. The infinity of possibilities that lie in between the integers. Here's a copy of Al-Uqlidasi's manuscript where he showed how the decimal point is used for the very first time. He describes it by using a dash. Here are the digits 1, 7, 9, 6, 8, and you can see there's a small dash over the 9 indicating the decimal place. The idea of the decimal point is so familiar to us that it's hard to understand how people managed without it. But like all great science, it's blindingly obvious after it's been discovered. The story of numbers and the decimal point hints that even over 1,000 years ago, science was becoming much more global. Ideas were spreading, emerging out of India, Greece, even China, and cross-fertilizing. And looking on a map that shows where people lived 1,000 years ago gave me my first insight into why medieval Islam would play such an important role in the development of science. Now look at which city lies at the center of the known world, a place where the widest range of peoples and ideas were bound to collide. It's the city where I was born, the capital of the Islamic Empire, Baghdad. Recent events mean I can no longer visit the city. But these are the home movies of my cousin Faris, filmed in the 1960s. The Baghdad we knew then looked nothing like the bomb-wrecked city it is now. I certainly grew up proud to be associated with one of the world's greatest cities. Baghdad was founded in 762 AD by the Caliph al-Mansur. His aim was to make it the glorious capital of a brand new empire, united by Islam, the rising religion of the time. The Abbasid caliphs had claimed their right to rule by declaring that they were directly related to the Prophet Muhammad, who had founded the new religion over 100 years earlier. But in that short time, the armies of Islam had conquered a vast territory. Starting in a small area around Medina, they moved rapidly out of the Arabian Peninsula and within a few decades had taken control of the Levant, North Africa, Spain and Persia.
I think one must bear in mind that this is an era in which people actually believed in God, and the dramatic successes of the Arabs as they poured out of Arabia was such that a lot of people did sort of observe and say they must have God on their side, this must be the true God. Some people did convert, or if they didn't convert, they did submit to Arab-Muslim political control for that reason.
By the early 8th century, Islamic caliphs ruled a vast territory. And like most successful emperors, from Caesar to Napoleon, they understood that political power and scientific know-how go hand in hand. There were many reasons for this. Some were practical. Medical knowledge could save lives. Military technology could win wars. Mathematics could help deal with the increasing complexities of the finances of state. And Islam as a religion also played a pivotal role. The Prophet himself had told believers to seek knowledge wherever they could find it, even if they had to go as far as China. And many Muslims, I'm sure, felt that to study and better understand God's creation was in itself a religious duty. But there were also other less edifying motives at play. To many in the ruling elite of the Islamic Empire, knowledge itself had a self-serving purpose, because possessing it was seen as proof of the new empire's superiority over the rest of the world. But with military and political success, the Islamic caliphs faced an inevitable problem. How do you sensibly govern a hugely diverse population? Although some of the empire had converted to Islam, they were still separated by huge distances and adhered to many different traditions and languages. In the 8th century AD, the empire's leader, the Caliph Abd al-Malik, had to find a way of administering this mishmash of languages. Like all the great figures of the Islamic Empire, Abd al-Malik lived in a culture without portraiture. All we have are later impressions of what he might have looked like. His solution was sweeping in scale and inadvertently laid the foundations of a scientific renaissance.
It was this Abd al-Malik ibn Marwan who said, this bureaucratic chaos has to stop. We cannot continue to run a government and govern all of this span of land with this Tower of Babel languages. So he wanted to govern it with a uniform language. That uniform language, of course, he wanted to be able to understand it, so he demanded that it be in Arabic.
But the choice of Arabic as the common language of the empire went beyond administrative convenience. The decision had extra force and persuasiveness because Islam's holy book, the Quran, is in Arabic, and Muslims therefore consider Arabic to be the language of God. The words of the Quran are so sacred that its text hasn't changed in over 1400 years. By comparison, English has changed dramatically in just 700 years. To our ears, Chaucer is almost unintelligible, whereas any Quran can be understood by anyone who reads Arabic. Making copies of the Quran has always been a specialized and highly respected job since the foundation of Islam. Calligraphy expert Naif Scarf, who lives in the Syrian capital Damascus, writes for mosques and in madrasas all over the country. These are words he's found himself writing over and over again, words of great significance for Muslims. They're the opening line to each chapter in the Quran. So what it says is Bism Illah Ar-Rahman Ar-Rahim, which means in the name of God, the most gracious and the most merciful.
بده يشكل مضبوط الفاعل المفعول بكذا يكون الكتابة صح ولا تفهم المعنى بشكل صحيح.
So it's saying the complexity of Arabic calligraphy was enforced on them because of the spread of Islam, because they were worried the meaning of the words in the Quran would be lost if it was read by people who don't speak Arabic. Then they wouldn't, not only would they misinterpret it, they just wouldn't be able to distinguish between different letters. So not only did they add dots on certain letters, they also added other little squiggly lines which changed the sound of vowels. And it was something that they put in place just to ensure that people were able to have the right pronunciation when they read the Quran. The consequences for science were immediate. Scholars from different lands who previously had no way of communicating now had a common language. And it was a language that was specially developed to be precise and unambiguous, which made it ideal for scientific and technical terms.
What this meant was the summoning into existence of a vast intellectual community where scholars from very different parts of the world could engage in dialogue, comparison, debate, argument, often very fierce argument, with each other. It was possible for scholars based in Cordoba in southern Spain to engage in literary and scientific debate with scholars from Baghdad or from Samarkand.
But I can tell you that scholars aren't motivated by the love of knowledge alone. There's nothing like a large hunk of cash to focus the mind. By the early 800s, the ruling elite of the Islamic Empire were pouring money into a truly ambitious project, which was global in scale and which was to have a profound impact on science. It was to scour the libraries of the world for scientific and philosophical manuscripts in any language. Greek, Syriac, Persian and Sanskrit, bring them to the empire and translate them into Arabic. This became known as the translation movement. The effort scholars put into finding ancient texts was astonishing. And one key reason for this is that bringing a book to the caliph, which he could add to his library, could be extremely lucrative.
The story goes that the Caliph al-Ma'mun was so obsessed that he would send his messengers out of Baghdad far and wide to distant lands just to get hold of books that he didn't possess for the translation movement. And anyone who brought him back a book that he didn't have, he'd repay him its weight in gold.
To give some sense of the extent of this activity, sort of between 750 and 950, somebody called An-Nadim, who wrote a list of sort of the intelligentsia of the Abbasid era, lists 70 translators. So it was quite a large cohort of people involved in translation, and obviously he only named the well-known. They could get up to 500 gold dinars a month, which is probably around $24,000, which is a huge sum of money for what they were doing. It was a very, very prestigious, well-paid, well-patronized activity.
And motivating this global acquisition of knowledge was a pressing practical concern, one that rarely crosses our minds today. This is the new library at Alexandria in Egypt. But fresh in the memory of many in the empire was the story of the destruction of the original library at Alexandria centuries earlier, and the shocking loss of thousands of years of accumulated knowledge.
One of the things that we tend to forget, because we live in an age of massive information storage and perfect communication, more or less, is the ever-present possibility of total loss. That was very, very important for medieval Islamic scholars. They knew extremely well that writings could be forgotten or buried or burnt or destroyed, that cities could pass away. And what we see in Baghdad or Cairo or Samarkand is exactly the gathering together, translation, analysis, accumulation, storage, and preservation of material that they were well aware could be entirely lost forever.
And if there was one branch of knowledge that everyone, from the mighty caliph to the humble trader, wanted to preserve and enhance, it was medicine. These were, after all, times when few lived to old age. Writings from the time remind us that what we might consider a relatively minor infection today could be a death sentence. Religious teachings, then, were not just a source of comfort. They were a constant reminder that we should never give up.
In the Hadith, which is the collected sayings of the Prophet Muhammad, it says, "Ma anzala Allahu da'an illa wa anzala lahu dawa'an," which means that God did not send down a disease without also sending down its cure.
It's statements like this that lead Muslims, even today, to believe that cures for all diseases are out there somewhere, and that we need to search to find them. To assess how this optimism actually affected Islamic medicine, I met up with Dr. Peter Porman in the Syrian capital Damascus. He's a leading expert on Islamic medicine who spends much of his time researching here in the Middle East.
What people don't realize is that the history of Islamic medicine is really the history of our medicine, because our medicine, the university medicine we used until the 19th century, it was based to a large extent on all this work of these Islamic physicians.
Islamic medicine built extensively on the foundations laid by the ancient Greeks. The most highly prized and among the first to be translated into Arabic were the medical manuscripts of the 3rd century Greek physician Galen.
Galen believed that a healthy body was one in balance, a balance of 4 types of fluids called humours, which circulate through the body, and any one of which, if out of balance, would cause illness and a change of temperament. The 4 humours were yellow bile, which, if in excess, would cause the patient to become bilious or bad-tempered and nauseous. Blood, too much of which would cause the patient to become sanguine or cheerful and flushed. Black bile, which in excess would cause the patient to become lethargic, melancholic, even depressed. And phlegm, which in excess would cause the patient to become phlegmatic or apathetic and emotionally detached. Galen argued that illnesses are caused by an imbalance in one of the humours, and so the cure lies in draining the body of some of that humour. And so he recommended techniques like cutting to induce bleeding or using emetics to induce vomiting.
But Islamic doctors were acutely aware that Galen and Greek medicine were only one source of medical knowledge. There were other traditions of medicine that they were equally keen to incorporate into their understanding of how the body functioned. Medieval Arabic texts refer to wise women, folk healers who provided medical drugs. This tradition continues today, as I found when I came across one for myself in the back streets of Hammamat in Tunisia. This is Arafat Nabil. She's been running her shop selling medicinal herbs and spices for over 20 years. She believes that her remedies can cure a wide range of medical ailments.
مثلا هذه عشبة
نعم.
اسمها شيح، تنحى الدود من البطن وتنحي جميع الأوجاع الداخلية. بعد من الزرنيخ ينحي الثعلبة، وبعشبة هذه اللي تراها أنت تويكة تنحي تقولوا البرص.
اوكي.
مثال هذوما مثلا كما هذه وهذه للصرع والجنون. صرع يحطها ويحط شويه في المخده نتاعو، ما عادش بك يشدوك الكريز هذاك.
وفي يعني مثلا من العصر اليوناني اقدم منها ما تستعمل ولا لو؟
والله اجي نقول لك كل ما هو قديم في الاعشاب انا نتبعه. فهمتني؟ باش نزيد معلومات.
In the back streets of Tunisia, this knowledge is still being used. But medieval Islamic doctors were also aware of other traditions of medicine from China and India. And yet another tradition of medical guidance came from within Islam itself, and takes some of its ideas from the Quran and some from the collected sayings of the Prophet, the Hadith. In a bookshop in Monastir in Tunisia, I found a copy of a very popular book, available right across the Islamic world.
This book is called The Prophet's Medicine, and see how old it is. The author was born between 691 and 751 Hijri, which places him in the 14th century. Here's an interesting bit where it deals with the plague. فَإِذَا سَمَعْتُمْ بِهِ بِأَرْضٍ فَلَا تَدْخُلُوا عَلَيْهِ وَإِذَا وَقَعَ بِأَرْضٍ وَأَنْتُمْ بِهَا فَلَا تَخْرُجُوا مِنْهَا فِرَارًا مِنْهُ. It says, if you come across a land where the plague has come down, then do not enter that land. And if the plague comes down onto your land and you're there, then do not leave your homes in the hope of escaping it. So it sort of makes a lot of sense. But here's quite an amusing part. It deals with epilepsy. And it says that the Greeks, or Galen, believed that epilepsy originated in the brain. So, however, they were ignorant. They didn't realize the true cause of epilepsy, which is the possession of the body by evil spirits. And it talks about the cure for epilepsy being exorcism.
Hardly scientific. But Islam's most tangible contribution to medicine is less in its specific remedies and more in its overarching philosophy. It is, after all, a religion whose central idea is that we should feel compassion for our fellow humans. And accompanied by Dr. Peter Porman, I'm going to see a physical, bricks and mortar manifestation of medieval Islamic compassion. This is the Nur al-Din Hospital, the leading hospital of the Islamic Empire, built here in Damascus and now a museum.
This was built in the 1150s, 1154 I believe. One of the ideas which are stipulated in Islam is the idea to be charitable, and
yes,
charity,
zakah, yes.
Exactly, and an obligation to give alms and stuff like that.
Yeah.
And so, if you're a ruler or if you have a lot of money, what you could do is obviously
you could really be charitable,
and set up like a nice hospital like this one.
Okay.
And within the hospital, Islam actively encouraged a high degree of religious tolerance, something we take for granted in modern secular society.
The hospital was open to all communities, so you would have Christians, you would have Jews, Muslims obviously, maybe other denominations, both as patients and also as practitioners. Like a Christian studies with a Muslim says my best student was a Jew, and so the medicine which was practiced here transcended religion.
I mean, typically, how many physicians would there be?
Well, it depends. Well, like for certain hospitals, we hear figures of like 24 or 28 physicians. Yes, the physicians would do the rounds in the mornings, you see, do their prescriptions and stuff like that.
Yes, hasn't changed over the ages. Yeah.
As a result of the translation movement, those physicians now became aware of the latest remedies from as far away as India and China. And as the new drugs filtered in from the rest of the world, hospitals started to set up a new kind of facility within their walls, the pharmacy. So this notion of a pharmacy in a hospital, is that a new innovation?
Well, the whole package, certainly, that's new. And what is interesting, if you look for innovation, again, like on the level of pharmacy, if you look at Baghdad or even Damascus, it's at this crossroad of cultures. So, and all sorts of new things come in, like musk, for instance, myrobalan. You have like Indian drugs. There's like an Indian pill, for instance, which is good against headaches and to, bad breath, but also, gives you sexual appetite and stuff like that. So,
Cures your headache, gives you fresh breath.
And gives you...
increased. And so it's like toothpaste, Viagra and aspirin.
That's right, all in one.
Fantastic.
Yeah. So, well, let's walk in here.
Peter wants to show me perhaps the most ghoulish aspect of Islamic medicine, surgery.
Here you have like a wonderful illustration. It appears that this is the first anatomical illustration in history. Like you see, it says adala, which means muscle. And so these are like the different muscles which move the eyelids.
So it was understood then that the muscles controlled the...
Oh, absolutely,
the lens in the eye.
Yeah, and moved the eyelid and stuff like that. So the other thing which we have here, which is really nice, is I think we have some... like ophthalmological instruments. For instance, it's a hook, could be used, for instance, like to kind of pull back your eyelid, that sort of thing. These instruments were very useful to the doctor.
Although these tools might look crude, eye surgery was one of Islamic medicine's great successes. One innovation was to improve an older technique for curing cataracts called couching, which in their hands had a success rate of over 60%.
In a living subject, the cornea would be clear and you'd be able to see the pupil clearly with the cataract sitting behind the pupil, the wide opacity.
To see how couching stands the test of time, I'm meeting up with eye surgeon Mr. Vic Sharma.
Right, the cataract is the lens inside the eye, which sits behind the pupil. As with time, with age, the lens gets cloudier and cloudier. And that's what is referred to as a cataract.
Okay. I've brought along a replica of a medieval couching knife and a description of the treatment by Al-Bukhasis, which is the Latin name for the great 10th century Islamic surgeon Al-Zahrawi.
He says you take the couching needle in your right hand, if it be the left eye, and so on, and then thrust the needle firmly in, at the same time rotating it with your hand until it penetrates the white of the eye, and you feel the needle has reached something empty. So he's talking about how to dislodge.
Exactly.
So, maybe you can show me. We've got some eyes here.
Yep, and I'll certainly give it a shot. And what they would have done would have attempted to go in just by the white of the eye, just at the edge where the cornea is. And then what they are attempting to do is to sweep around, trying to break all those ligaments of that lens and trying to get the lens to drop away from the pupil to allow more light to enter in through the pupil and to brighten the subject's vision.
But of course you haven't got the capacity to focus.
Oh yeah, you haven't got a lens now, so that was a big problem until people started compensating that with specs later on.
Right. What is your feeling about how advanced and successful?
Well, they were on the general ballpark. They were at the right place. They were trying to remove the cataract away from the visual axis.
They understood the anatomy of the eye.
Exactly. They had some understanding of the anatomy of the eye, and that the lens was behind the pupil, and that's what was causing the visual loss. And so removing that, and that general principle is still the same.
Right.
And there are still accounts of it being used in certain parts of the world presently.
Looking back at medieval Islamic medicine with modern scientific eyes is frustrating. They take as true many things we know to be nonsense. But on the other hand, their desire to deal with this vast subject logically and systematically is admirable and truly marks a break with the past. One Islamic scholar, more than any other, embodies the synthesis of religion, faith and reason. His name was Ibn Sina, or Avicenna, as he's known in the West. He was a polymath who clearly thrived in intellectual and courtly circles. In 1025, he completed this, Al-Qanun fil Tib, or the Canon of Medicine. In it, Ibn Sina collated and expanded on all that had gone before him, medical ideas from Greece to India, and turned them into a single work. So how would you place this book in a historical context?
Oh, it's hugely important. I mean, there are a few books which are as important as the canon, because what this encyclopedia does, it kind of, sweeps away everything else. It becomes a textbook. It supersedes a lot of other texts, and people even complain that, it's so good, it's so tightly organized, it's so easily accessible that, people forget to read the Greek sources in Arabic translations. This whole first book, this is the first book, contains what we call the kulliyat, the general principles. So it's all about how the human body works, how diseases work in general. The second book contains diseases of what we sometimes call from tip to toe, like from tip to toe. So he starts with the diseases of the head, and then he moves down, like the eyes, the ears, the nose, the mouth, and normally they end up at the sexual organs, you see.
At first sight, the sheer ambition of the 3 volumes is hugely impressive. Here's an attempt at diagnosis and cure for diseases as diverse as depression, meningitis and smallpox. And there's even detailed chapters on more common problems.
So, for instance, here you have headaches.
So different kinds of headaches.
في العلاج الصداع الحادث عن الروائح الطيبة. So headaches caused by pleasant, fragrant smells.
And then he's also got al-hadith min al-khimar, so hangovers.
Different kinds of jima. You can get headache from sex.
Is that right?
Well, I mean, hasn't happened to me yet, but I mean, Let's see. So, the treatment of headache caused by sex. ويجب لمن يعتريه ذلك عقب الجماع وبامتلاء أن يبدأ بالفast. So if somebody has or is befallen by, suffers from a headache after sex, and he also has a repletion, so he has too many superfluities or something like that, so يجب أن يبدأ بالفast. One has to first resort to venesection or bloodletting. ثم بالإسهال, and then you should use purging. In وجب كل واحد منهما. For both of them, I mean, bloodletting and purging are necessary.
A lot of the stuff in here sounds like nonsense, of course, because this is not modern medicine.
No, it's not.
So how long was this taken seriously?
Well, the fundamental ideas contained here about how the body works, I mean, they haven't changed until the early 19th century. I mean, there was progress, obviously, on certain levels, but the essence was the same. And then came the big break with the discovery of bacteria and viruses and things like that. And from the second half of the 19th century onward, medicine was totally revolutionized.
Ibn Sina's canon of medicine is a landmark in the history of the subject. Although much of the medical science it espouses we know now to be terribly misguided, its value lies in accumulating the best knowledge in the world at the time into one accessible, organized text. The canon would give future generations something to rewrite. Cataloguing the world's medical knowledge has clear and obvious benefits. But the Islamic Empire's obsession to uncover the knowledge of the ancients went beyond practical matters like medicine. Many, like the Caliph al-Ma'mun, believed that the people of antiquity possessed dark, even magical powers. And what's more, new evidence is coming to light to show just how hard Islamic scientists worked to rediscover them. To find out about that story, I have to visit the harsh, burnt yellow of the Sahara Desert in Egypt. There I am to meet an academic who wants to show me how the translation movement took the Arabs to Egypt on a quest to break a code, which they thought hid the secret of the dark art of alchemy. This is Saqqara, a necropolis or graveyard of the ancient pharaohs. Over a 10-acre site, it's a collection of burial chambers and step pyramids that were built in the 3rd millennium before Christ. These are said to be among the oldest stone buildings in the world.
Mind the step here?
Archaeologist Dr. Okasha Al-Dali is my guide. He was about to reveal the most astonishing story of my journey so far. Look at that. Like most people, I believed that Egyptian hieroglyphs had remained completely undeciphered until the 19th century. Then came the chance discovery of the famous Rosetta Stone. This stone had the same inscription written in both hieroglyphs and Greek. It provided the crucial clues which British and French scholars used to decipher the writings of ancient Egypt. That's the usual story one hears. But Dr. Al-Dali has made a discovery that dramatically alters it. He has recently unearthed a number of rare works by the Islamic scholar Ibn Wahshiyya. What he did was figure out a correspondence between hieroglyphs like these and letters in the Arabic alphabet.
If you look here, for example, at Ibn Wahshiyya's manuscript, you see he's giving us the Egyptian hieroglyphic signs that have phonetic value
underneath.
Yes, and they have the phonetic value in Arabic underneath. So look very carefully at this one. He says "seen" underneath that seat.
Yes.
Now look at this seat here. That is S. That seat in Egyptian hieroglyphic is used for the sign S, seen, which is what you see here, seen. That is the name of the god Osiris, Osiris.
Oh, with an S.
That's the seen. This is the letter H. This one here.
This is the ha.
The water wave
Right.
is the letter N, or noon in Arabic. T, and the letter F.
These are all letters.
These are all letters. But then he realized...
But how did he decipher the hieroglyphs?
The one good thing about the early Arab scholars was their ability to link ancient Egyptian language, we call hieroglyphic, to link it with their own contemporary Coptic. They realized that Coptic is nothing but the later stage of ancient Egyptian language.
And they realized this because the translation movement had literally placed hundreds of Coptic texts into their hands. The scholars could now see a direct link between hieroglyphs and Arabic. What fraction of these symbols would have been correctly deciphered?
They got about 14 letters. They cracked more than half of the Egyptian hieroglyphic correctly. So that was a remarkable achievement for people in the 9th century, 10th century.
Well, that's probably the biggest revelation for me so far on my travels, that Egyptology didn't begin in the 19th century. Yet again, it seems that Islamic scholars actually cracked hieroglyphics, and they cracked it for strange reasons. They cracked it because they were interested in astrology and alchemy. But here is another example of this amazing translation movement. They weren't just translating Greek and Indian and Persian texts, they were translating Egyptian hieroglyphics as well. Absolutely incredible.
Unfortunately for the Caliph Al-Ma'mun, the hieroglyphs contained no alchemical secrets. But what this story reveals to me is the insatiable curiosity Islamic scholars had about the world. They were desperate to absorb knowledge from all cultures purely on merit, with no qualms about the places or religions from which it came.
Most intellectual traditions, including, if I may say so, our own, tend to work very hard to keep everybody else out. Whereas here we have an example of an enterprise which is desperate, curious, to turn itself into a net importer of intellectual product. And that's a very important lesson for the history of the sciences.
I was soon to see just how dramatically this fueled scientific innovation. But it's worth remembering that the translation movement wasn't just about science and medicine. As the capital Baghdad sat in the center of a vast, successful empire, it became home to an extraordinary flourishing of all kinds of culture. For this is the time described by 1001 Nights of great and generous caliphs, magic carpets, great journeys, but also ambitious buildings, music, dance, storytellers and the arts. Baghdad was such a cultured and vibrant city that one traveller of the time wrote, "There is none more learned than their scholars, more cogent than their theologians, more poetic than their poets, or more reckless than their rakes." It really must have felt like Baghdad and the Arabic Empire were the world leaders in civilization and culture. To be part of that city's growing intellectual elite must have been as exciting as it gets.
It was a new Muslim city. It only started to be built in 756. So it has that sort of sense of almost being on a frontier, of being something new, of being something different. It was full of courtiers, it was full of sort of nouveau riche individuals who were trying to make their way at the Abbasid court. And it is the sort of a place, if you like, where innovation is valued and appreciated.
At the heart of the city's intellectual life was a system called the Majlis. Now, the word Majlis could probably best be translated as salon or talking house. In 9th century Baghdad, what this meant was that the city's elite, the caliph, his courtiers, generals, and the aristocracy, would hold regular meetings, you might call them seminars or discussions, during which the city's cleverest men, the philosophers, theologians, astronomers, and logicians, would gather to discuss and debate their ideas.
It was not the case that people were expected to adhere to a particular line or adopt a particular religion. They were allowed to express their own sentiments and their own views very freely. The point was that they should do so in elegant Arabic and a good logical reasoning.
The effect of the Majlis was to create a heady mix of money and brains, with the best minds in the empire swapping ideas while simultaneously engaged in fierce competition for patronage.
It's at this point my investigation into the first wave of Islamic science returns me to the man we first met at the beginning of this story in the back streets of Cairo, the great mathematician who brought the West the decimal system.
Out of the very heart of this intellectual whirlwind came Al-Khwarizmi, mathematician, astronomer, courtier, and favourite of the Caliph Al-Ma'mun. He was a product of his age, an immigré from eastern Persia into Baghdad, surrounded by books, well-versed in learning from Greece, Persia, India, and China, and fearless in his thinking.
Al-Khwarizmi brought together two very different mathematical traditions and synthesized them into something new.
The capacity to have on your desk simultaneously two very different kinds of mathematics presses on models of what counts as calculation, what counts as measurement, and I think accelerates the process of intellectual change.
The first of these traditions came from the Greek-speaking world. Greek mathematics dealt mainly with geometry, the science of shapes like triangles, circles, and polygons, and how to calculate area and volume. The other great mathematical tradition Al-Khwarizmi inherited came from India. They'd invented the 10-symbol decimal system, which made calculating much simpler.
Thanks to the translation movement, Al-Khwarizmi was in the astonishingly lucky position of having access to both Greek and Indian mathematical traditions. He was able to combine geometrical intuition with arithmetic precision, Greek pictures and Indian symbols, inspiring a new form of mathematical thinking that today we call algebra.
As a physicist, I've spent much of my life doing algebra, and I can't overstate its importance in science. But it is a strange idea. I remember being perplexed when my math teacher first started talking about mathematics not using numbers, but with symbols like X and Y. It's an incredibly liberating idea because it allows you to solve problems without getting bogged down in messy numerical calculations.
So we have here this priceless manuscript, Kitab al-Khwarizmi, Al-Khwarizmi's book, and
Professor Ian Stewart has studied algebra for much of his working life. Together, we looked at an early copy of the book in which the idea really took form.
I see here, although it's written sort of in the margin, the title of the book, Al-Jabr wal-Muqabala. So that's the first time the word Al-Jabr appears.
Algebra.
Algebra, that's where our word algebra comes from. Now, what I found very early on is that he said, I discovered that people require three kinds of numbers. Judur wa amwal wa adad, so roots, squares and numbers. So what is he trying to do here?
This is what we would now call x and x squared. This is quadratic equations. This really is algebra. So he's setting you up for a book about how to solve equations by algebraic methods.
Okay, now quadratic equations I thought were around and being solved long before Khwarizmi, back to Babylonian times. So, you know, what's the big deal about this book?
It's the point of view. He treats root and square as if they're objects in their own right. They're not just some number that we're trying to find out. They're a process you apply. What Al-Khwarizmi is thinking of is square means take the root and multiply by itself. And that recipe is true whatever the root might be. If it's 5, it's 5 times 5, it's 25. If it's 3, it's 3 times 3. He's giving you a general recipe, now called an algorithm, after him.
The algorithm comes from...
It comes from... It's another word that comes from Al-Khwarizmi, yes.
Now, he talks about this procedure here on the next page. You take the number multiplying the root, and then you halve it, and then you multiply it by itself. Then you add it to the other number and take the square root. That's the algorithm, is it?
That's right, and this is where you see the difference, because previous writers on the subject would have said things like, take half of 10, which is 5, square that, which is 25, and then they do another problem, take half of 12, which is 6, square that, which is 36, and they'd run you through this same process over and over again with different numbers, and it would be up to you to infer how to do it on the next problem.
But he doesn't do that.
He doesn't do that. He says, take half the root. Whatever the root is, take half the root. So half the root is actually an object. If the root is an object, half the root is an object.
So you don't have to have in your mind what that root stands for.
You can forget about what it stands for. When you come to square it, you just know, okay, I should square this thing. I don't care what the thing is. So you abandon temporarily this link with specific numbers, manipulate the new objects according to the rules that his book is explaining, and then the numbers that these objects represent in your particular problem will miraculously appear at the end, and you'll end up with x equals 3, or whatever it is.
So how revolutionary do you regard Al-Khwarizmi's work?
He made it possible for algebra to exist as a subject in its own right, rather than as a technique for finding numbers. The least interesting bit of an algebraic calculation is when you get to the end and discover that x equals 3. It's the route you take to get there. But if it was a special route for each problem and a different route for each problem, that wouldn't be interesting either. It would just be a big mess. There's this beautiful general series of principles, and if you understand those, then you really understand algebra.
is the true global importance of algebra? It's been used throughout the ages to solve all sorts of problems. Let the mass of the cannonball be m. Let the distance it has to travel be d. Use algebra to work out the optimum angle you have to point your cannon. That sort of knowledge wins wars. Or let's call the speed of light c, the change in mass of an atomic nucleus m, and then calculate the energy released with the following algebraic formula: E equals mc squared. Mastery of that information truly is power. Algebra has helped create the modern world. Our science is unimaginable without it. It sums up so much that was remarkable about medieval Islamic science, taking ideas from Greece and India, combining and enhancing them. Similarly, modern medicine owes a considerable debt to the work of the Islamic physicians. But I think the real story of what happened to science in the Islamic world in the 8th and 9th centuries tells us more than any single discovery. What it really tells us is about the universal truth of science itself. I believe that the first great achievement of the medieval Islamic scientists was to prove that science isn't Islamic, or Hindu, or Hellenistic, or Jewish, Buddhist, or Christian. It cannot be claimed by any one culture. Before Islam, science was spread across the world. But the scholars of medieval Islam pieced together this giant scientific jigsaw by absorbing knowledge that had originated from far beyond their own empire's borders. This great synthesis produced not just new science, but showed for the first time that science as an enterprise transcends political borders and religious affiliations. It's a body of knowledge that benefits all humans. Now that's an idea that's as relevant and as inspiring as ever.
In the next episode, I investigate how one of the most important ideas in the world arose in the Islamic Empire. I discover how mathematics and experimentation fused together as the empire embraced a medieval industrial revolution. And in Cairo, I find out how these ideas led directly to today's world of science and technology.
And that next episode of Science in Islam is here on BBC 4 at 9 next Monday. On Wednesday here on BBC 4, we spend an evening looking at, rather than through, the world's strongest and most famous telescopes, starting with a Sky at Night special at 8.